for NLP. It is for all the what I'm teaching now is generally for data science. Any other you take NLP, computer vision, voice, whatever it is, audio, anything you can learn. So you have completed running. I told you in just with people who don't know programming also can do this. So this is where you're importing all the libraries. So any doubt in this, you're importing all the libraries here: Matplotlib, NumPy, TensorFlow as TF, TensorFlow underscore hub as hub. This is alias. And functools and OS are the other libraries which you require. Then you're just printing out what TF version, what hub version, and the other important things. But the maximum is the main point is here you're importing the libraries, relevant libraries. So here these are functions for loading, image loading and visualization, which you don't have to understand anything. That is for to show you like this. It is coming like this: content, image, URL, style. For creating this template, they have put the helper functions. You don't have to, it's not necessary you should create such helper functions and all. So you don't have to understand. So any content image, what is style transfer? You have a content image, you have a style image, you are transferring the style to the content image. To the content image, you are transferring the style and you will get a stylized image. This is the input, this is the, these two are inputs, and you want to get an output like this. So to achieve this, with just single line of code, you can give any image from Wikipedia and you can test it. With just single line of code, I'm taking the pre-trained model from this URL where the model is already trained and open sourced. Some good human being has already trained the model and open sourced it. So anyone in the world can use it. You can also train some models and open source it for anyone to use. Then you will become an open source contributor. You can contribute to Hugging Face, which is very famous for NLP. You can contribute to Torch Hub if you like PyTorch. You can contribute to TensorFlow Hub if you like TensorFlow. For anything, not just require specific to NLP, you can contribute to image, vision, anything. So some good human being has contributed the pre-trained model. We'll take the URL of the model. When you click it, this is where that model is. Somebody has given, you can copy the URL. You can download the model if you want, or you can open a sample code. You can get it from the Colab notebook also. With just that model, you are storing it in a variable. Then I'm calling the method hub.load where I'm passing the location of the model. That's it. I'm just taking the hub.load model, passing the two input parameters, which is the content image and style image. And I'm getting the output, which I can print it as stylized image. So with just single line of code, I was able to build a model and achieve what I want because I'm using a pre-trained model. You can try it with other images as well. You can give any image, JPG, direct URL link from the Wikipedia or any two image you can see, and you can check the output as well. So I'm taking the URL of the model, storing it in a variable, calling hub.load, passing that location. That's it. I built a model with just one line of code. Hub.load. I built a model with just single line of code. Passing two inputs to it, content image and style image, and getting the output. Anybody didn't understand the high level overview of what is happening here?
Yeah, ma'am.
So TF is a great tool for researchers who don't have any programming experience to come and prototype. What is the requirement for programming knowledge here? There are many such models to do the TensorFlow hub. That URL of the model you come, the template is ready, you just replace. If you want to use a different model, replace the URL here. Then run the application, you will get the solution. There's no programming knowledge required. You don't even have to know Python. So it is a good tool for the researchers who don't have any programming knowledge, any knowledge on machine learning also can come and test it out. At the same time, if you already know machine learning, you want to quickly prototype some models in NLP or vision, that also you can do. Or if you don't have enough sufficient compute power, this is already a pre-trained model, so you don't have to do any multiple retrainings. This is already training. So it is used for multiple stakeholders. This example is not relevant to NLP. I'm just showing the uses of TensorFlow Hub, how you can use a pre-trained model and solve your problem. And the variety of stakeholders who can get benefited of because using such repositories. You can also contribute, become an open source contributor by training a model, open sourcing it for everyone else in the world to use. By that way, you can become an open source contributor as well. Anybody did not understand the significance of TF Hub? Please let me know. At the high level, you did not understand, you let me know. At the high level, what it is, you understood, all of you? Can we move to a NLP specific example? At the high level, all of you understood?
Yeah, clear.
Okay, so can we move to an NLP specific example and see how we can use TFF for achieving the same in NLP?
Yes, ma'am.
Yeah.
Can somebody take that link and paste it once again in the this meeting so that all of you can take the NLP example is here.
I already did actually.
Ma'am, it's already pasted.
It's already there. Second example.
Yes, ma'am.
Yeah, all of you opened it. Text classification, all of you opened it. Click on runtime and all.
Actually, it will take some time because there are 30 epochs are there to train the model.
Not a problem. Take 2-3 minutes, let it run. For the time that who and all did not understand TensorFlow Hub, you can go through that style transfer to understand it better till it runs. Digest this concept till it runs. Listen carefully because after this example, you are going to replicate the same for one of the data sets. Pay attention in the class.
Ma'am, next time, could you try joining through Reva ID so that you will have the chat option?
Sure. I'll join after afternoon class. I'll join using Revive.
Yes, ma'am.
All of you have access to this notebook? It's there in the WhatsApp.
Yes, ma'am. I have got it fully.
Okay. All right. Till it runs, let's go to the example and see what it is. So you're going to use IMDb data set here. You have to classify if it is positive or a negative review. You classified spam or ham. You had a good review data set also. You classified positive or negative reviews. Disaster or not disaster. All these use cases. Same way you have IMDb Internet Movie database For each review, you have to classify if the review is positive or the review is negative. I just talked about TFHub and how important TFHub is for people who are not having strong programming background and for researchers and scientists. Now I'm going to also talk about another thing available as TensorFlow datasets. So TensorFlow datasets is another such module for people who want to quickly come and if they're writing a research paper or something, algorithms or something like that, they want to quickly test it out in a preloaded data set. They can come and they can test out TensorFlow datasets. So TensorFlow datasets for each of the problem statement, for example, you can take text. For under text, there are so many preloaded data sets. So you have Hello Swag, open books data set. So many data sets are preloaded, neatly cleaned and available for you. You don't have to spend time cleaning it. There are so many data sets under text, images, video, audio, under several problem statements. They are neatly cleaned and they are given to you. So we are going to use a preloaded data set in this example. So that preloaded data set is called IMDb reviews, which is already cleaned and given to you. We can access these preloaded data sets from TensorFlow datasets using tfds.load. We'll be able to access all the data sets in the TensorFlow. If you give the name of the data set, you can retrieve the data set. It's already clean, pre-processed and all of it. So it's a great thing for researchers. You're building or writing a new algorithm. You can come and use these preloaded tests to check out the significance of your algorithm. I'm going to, if I just have to mention split, train and test, it will automatically split into test and train buckets. So now I have training example, training labels, test example, test labels neatly given. So without doing any feature engineering, any pre-processing, I got a clean data sets from this repository, TensorFlow data sets for images, video, audio, text, tabular data for all the categories and multiple preloaded data sets. The advantage of using this preloaded data set is it is already clean and using API, I can access the clean data set. So using API tf.ds, I access the name, I gave the name IMDb underscore reviews, and I access the data set which is split into train and test. Now I have 25,000 training examples, 25,000 test entries. So this is how the train labels look like: 0 and 1, positive review, negative review. All the pre-processing, everything already is done. From the TensorFlow hub, I'm going to download the user model from this link. I will go to the link and see. So this is a pre-trained model which we are going to use. This contains a text embedding. This text embedding is what we are going to use as a feature. Word embeddings, you can use it as a feature, I told you, right? So it is the text embedding. If you come to this URL, you can download the URL of the model, or you can download directly the model also. How to use a URL is given here. That is, to get the embeddings, I'll just hub.load, I'll give the location of the model and I'll store the location in a variable. Then this is nothing but the embeddings. From this model, I'll be getting the word embeddings, which I can use it as a first layer in my neural network model. So this is a basic neural network model. There is an API called keras.sequential. You can create neural network model using two APIs. One is functional and keras functional API and sequential API. There are two ways to create model. We are using the first way, which is keras.sequential. You will understand in the next module what is deep learning, how to create using TensorFlow now. But you understand there are two ways. One is using keras.sequential API we can use. What is sequential means? It will do, we will be creating layers sequentially, one after the other. Functional API means outputs of multiple layers can be given as an input to a single layer. There are much more advanced sophistication you can do in functional API. But sequential API, sequentially it will go. The output of previous layer will be given as input to the next layer. Like that, you will go in sequence. So there are two types where you can create neural network models. One is sequential and functional. Functional means output of multiple layers can be given as input to a single layer. You can do advanced customization in functional API. Next module, they'll teach you in advanced way. But here now you understand there is two things, sequential and functional. Sequential means you will give the output of one layer is going to be the input. Sequentially, we will build layers. So we will first call that layer and we'll store a variable model. Now we are going to add the first layer as the embedding which we got from this pre-trained model will be the first layer. Then we will add two more layers. We will add two more layers because we have a model. We can't use the, instead of using the model directly, we'll make modifications to use for this use case. So this is a single class classification model where you're just going to classify whether it is 0 or 1. But there can be multi-class classification as well. So since this is a single class classification, my final layer is having just a single node. This node will indicate if it is 0 or 1. Instead of having just, I can directly put this after this embedding layer, but instead I'm just adding two more layers. That's it. And you will understand what is activation function and all in the next module. That's it. I've built a model using sequential API with just single line of code. I've just built a model. This is my neural network model. So you're taking the word embeddings from here and you can print out the word embeddings. It's just nothing but vectors. And then you're building a model here. The first model is that word embedding layer model. Then you can add two more layers. The final layer will be just having single neuron, which indicates that it is going to, it will be the node which tells us whether it is 0 positive review or negative review. So we have built a neural network model. We also have, see, you can have multiple layers. You don't have to stop with two layers. Next module, they'll teach you in deep learning how many layers you can add, what is the significance of these layers and all that. They'll teach you next module. But for now, 16 means it's 16 nodes. This one means it is single node. So you take any deep learning architecture. Next module, they'll teach you. For now, you understand basic that things, that is more than enough. These are the nodes. So up to these first three rows that the embedding is already given to us. This last row here, there are three nodes, which means it's a multi-class classification. Here we have last node is single node, output node. And we can have any number of hidden layers. We are just having single hidden layer, that's all. The single hidden layer we are having, this is a single hidden layer. And the final output layer is this. You can have any number of hidden layers you want. We are just having one single hidden layer, but you can add multiple hidden layers. That is up to you. And one final output. So with not much deep learning knowledge, we were able to build a deep learning model without much knowledge. So this template is already available. If you want to use a different model, just change the URL. That's it. You can use the same template. You don't have to type every line of code. Template is already available. You just, if you want to use a different model, then just change model URL, different pre-trained URL. There are also other concepts like compile and fit. So in machine learning already you might have learned about fit, but compile might be very new to you. So compile is nothing but there are some concepts like optimizer, loss functions you would have learned in machine learning itself. So metrics and loss functions in machine learning itself you would have learned. So machine learning you will have learned an optimizer called SGD. Stochastic gradient descent would have been taught in machine learning, right? So what was the optimizer which was taught in machine learning? Gradient descent algorithm and all was taught in machine learning. Can somebody open your mouth? Hello?
Yeah, I don't
Ma'am,
remember actually being
no,
taught in
I
this.
think we didn't. It will be. I'm not sure. Actually, we discussed about it, but yeah, I think it was discussed, but not in that great detail.
No,
So
but you
Professor
know
Simha talked about ReLU function and gradient descent earlier, but not as part of some hands-on assignment or anything.
so don't worry. Deep learning module, they'll teach you all the optimizers in detail. They'll teach you what is atom and everything in detail. But you know, you are familiar with it, right? What is an optimizer? You have been taught gradient descent in your machine learning, right? It is not something totally new to you. You've been exposed to it. For machine learning, you are dealing with stochastic gradient descent. For deep learning, there are a set of optimizers which are much more better than the stochastic gradient descent. That one of them is atom, but there is other optimizers like RMS prop. These are different algorithms.
Ma'am, we
So
have done hyperparameter optimization. That's the only thing that I remember as of now.
So your algorithm internally will do the stochastic gradient descent and all. That is not visible to you because you are using scikit-learn. You are not writing any algorithm from the scratch, right? If you write algorithm from the scratch, you have used gradient descent and all. But you are in theory, they covered you the topic or what? Was
In
the
theory,
stochastic gradient descent algorithm covered in theory of machine learning? If they have not covered, that should have been covered actually.
Ma'am, I don't think we have covered that.
Okay,
Like,
in machine learning, it should have been covered, but deep learning, they will be covered. They should be covering in NLP, we won't cover optimization algorithms and all. It should be covered either in deep learning or it should be covered in NLP. But I will tell you what it is. I will not be able to cover the algorithm of Adam is not the job here. That is the job of your instructor in machine learning. They should have exposed you to. This is a standard curriculum format. In machine learning, they should have exposed you to what is gradient descent and what is stochastic gradient descent algorithm. In deep learning, they will teach you if you are using SGD in machine learning. In deep learning, there are some algorithms which works really well, which is Adam, RMS prop, and many such algorithms. So they will teach you these algorithms in detail in deep learning class. But what is optimizer is you should really know.
ma'am,
So,
can I try to explain?
yeah, please.
I'm just trying to explain my simple, probably the simple way I understood it. The thing is that it is a function again, optimizer, and the purpose of a optimizer function is to, um, find the optimum values through which you can get the maximum output or maximum accuracy from the model.
Yeah, good job, good try. So the reason why we have an optimizer is all of you have to optimize a certain metric. So we have, for example, here we have to keep the, if your objective is to keep your loss function as low as possible, or you might want to increase your accuracy, or you will have an objective function, any objective function for building a model. So the value of the optimizer is to keep your objective function as low as possible. So if you want to optimize your loss, keep your error low, then the optimizer's job is to keep your error as low as possible. So that is what it will do. It will minimize your objective function. So whatever your objective function, that it will keep it as low as possible. So that is the job of an optimizer. You have several optimizer functions like Adam, RMS prop. In machine learning, they should have taught you stochastic gradient descent. If they have not taught, don't worry. Next module, they'll teach you the mathematics and the much more advanced concept. What is Adam, RMS prop, everything will be taught to you in the deep learning modules. If they have not already covered in machine learning, that means they are going to cover it in deep learning. They'll cover all the optimization algorithms in your deep learning module. For now, you understand it's a function, that's all. And you have loss and metrics by which you will measure how good your model is and all that. All that there will be a function called compiler under which there are several optimizer functions available. You will tell what function to use and you will tell what loss function to use and you will tell for your model what the accuracy you're going to keep. And then you're doing train trace split, you're taking train values at 10,000 examples and then test value validation set as 10,000, another 10,000 example. Then you will do a model fit. You're taking this small mini batch of data sets and here you're training, but you can train your entire data sets, training data set as well. Here they're training only partial train, but you can train your entire data set. And then you can evaluate your test data set and you will be able to get the accuracy. You're getting 87% accuracy. You can plot your graphs. So if you want to use the same to any other use case, what you should do, you can use the same pre-trained model to get the embeddings. You've already done 2 use cases, right? 3 use cases. Natural language processing, spam or ham, and Goodreads. Which one of the 3 is easiest? Can anybody say which one of the three use cases are you finding it easy?
Spam ham is easier.
Okay, if spam ham is easy, you can take that use case. You don't have to modify any line. Instead of using IMDb dataset, you just use your own dataset, which is spam ham. You have already finished all the cleaned everything, right? You split it into train and test where you build a neural network model. You don't have to modify anything. Use the same model. Use the same model summary. Use the same compile and all. Don't change all these things. You just use the data set alone. You're going to use different thing. You can use any of the three use cases which we have seen already. Use a different data set. Solve the problem using deep learning.
It's an
Understood
assignment.
what is the assignment?
Okay, ma'am.
Now you are going to do it. You have 25 minutes time, 35 minutes time, and after that you have lunch break. And then lunch break is 1 to 2. 2 o'clock when you come, you should have completed it. So you don't have to, instead of IMD data sets, any of the data sets which you used already, cleaned data set, you use it. Remaining part, you don't have to change anything. You give the same thing. You use the same pre-trained model, use the same model, and use the same optimizer, everything else same. Just the data set, instead of trying on the IMDb, you try it in any of the one of the data sets. If you are very good in it, you are able to follow, try it in all three data sets. If you are not able to new to programming, try it in one data sets. You can combine and do your work. It's not necessary you should do it alone. Whoever is new to programming, please find one programming partner. That is somebody who's coming from a programming. If you're not new to, if you're not comfortable with programming, then you find somebody in the team who's very strong with programming and do pairing work. That is, you just keep watching what the other person is doing. Whatever assignment is doing, you do it as a combined assignment with that person, so that that person will help you out, and don't do it alone. Anybody who are all new to programming, please don't do it alone. Join with somebody who is very strong, and tag with them and do all the assignments, so that there's always somebody to help you out. For the other people, you can do it solo. If you're already very strong with programming and things, coming from a programming background, do it solo. For the people who are new, you tag with somebody and do it. Problem statement is, you have already dealt with three use cases in the previous thing. Take the same use case. Instead of IMDb, you put that use case, and remaining part, everything is same. You solved using machine learning last time. Now you solve it using deep learning. See, many things you won't be able to understand every line of code. That deep learning module is coming next. Only after that module, you will be able to get a clear picture. For now, what you are expected to do is take that, instead of this IMDb use case, you just try this deep learning model with any of the three use cases which you have tagged already. Non-programming students, please combine and do it with somebody strong in the class. Whoever is strong in programming, do a combined work with them. You have 33 minutes now. Then that should be sufficient to complete this task. Then lunch break from 1 to 2 o'clock. We'll catch up at 2 o'clock. So you have sufficient time. You can finish off the lunch fast, and you can do it as well. So three topics have to be covered today. One is the text classification using deep learning, introduction to that. Because we will be doing a lot of deep learning in the next 2 days, third and fourth day. So you should understand basic deep learning at least. You're going to learn RN and LSTM and all. So you should understand how it is in TensorFlow, it is coded and all the basic format. So can we catch at 2 o'clock? All of you understood what you're supposed to do? You have the template of this notebook as well, right?
Yes, ma'am. Ma'am,
Yeah.
are you supposed to upload it on LMS?
Yes. So the same thing, you're not going to type. I didn't ask you to type deep learning. The model is already, pre-trained model is already in the URL. The model syntax is already there. Model compiling, everything is already there. You are not expected to write your own model and all. What you're expected to do is change the data sets and make it work in one of the three data sets. That's all. So can we catch at 2 o'clock? This is a very simple example. Please do it. And anybody who's not strong in programming, please find a strong partner or do all the assignments with that strong partner, so that that partner is able to help you understand and make you to work. Don't do it alone. All right, let's catch at 2 o'clock. Bye.
Thank you.